this episode, we focus on a modern reality of software that surprises many beginners. Most applications are not built from scratch. They are assembled from many dependencies and components that come from elsewhere. A dependency might be a library you include to handle a feature, a framework that shapes how your application works, or a component that provides a critical function like data parsing or authentication support. This approach makes development faster, but it also means your application inherits risk from code you did not write and may not fully understand. Managing dependency and component risk is about keeping that inherited risk from turning into unexpected security problems during builds and releases. It is not enough to say we use reputable libraries, because even well-known components can have vulnerabilities, and even small components can become critical if they sit on a sensitive path. The challenge becomes bigger when you realize that dependencies change over time as versions update, new features are added, and build pipelines pull in new artifacts automatically. Our goal is to explain what dependency and component risk is, why it is a major security issue, and how teams manage it across the build pipeline and release process without turning development into a constant emergency. A useful starting point is to understand why dependencies are so common and why they create a unique kind of risk. Developers use dependencies because reinventing common functions is slow and error-prone, and shared libraries can provide mature, tested solutions. The trade-off is that you are trusting the dependency's code, the dependency's maintenance, and the process by which you acquire it. Risk appears when a dependency has a vulnerability, when it behaves differently than you expect, or when it is replaced or altered in a way you did not plan. Beginners sometimes think that vulnerabilities are only created by their own code, but the truth is that a single vulnerable component can create a serious weakness even if your application code is otherwise careful. Another aspect is that dependencies can be indirect, meaning you might include one library that brings in several others under the hood, creating a chain of inherited risk. This chain can be hard to see without deliberate tracking, which is why dependency risk can surprise teams late. Dependency management is also about stability, because sudden changes in components can cause unpredictable behavior that affects both security and reliability. When you recognize that modern software is a supply chain of code, dependency risk becomes easier to understand and more important to manage. Component risk is broader than just known vulnerabilities, because a component can be risky for many reasons. A component might be unmaintained, meaning it no longer receives updates or fixes, which increases long-term exposure. It might have a risky design, such as unsafe default behaviors, confusing configuration, or a history of security issues. It might introduce licensing or provenance concerns, meaning you cannot confidently say where it came from or whether it is allowed to be used. It might also expand the application's attack surface by adding features and code paths that increase complexity. Beginners often focus on the idea of a bug, but component risk includes the likelihood of future bugs and the difficulty of responding when something goes wrong. If you depend on a component that is deeply embedded in your application, replacing it quickly during an emergency might be difficult. This is why dependency decisions are not only technical convenience decisions, they are risk decisions. Good teams treat dependencies like important building materials, because if a core material is weak, the whole structure is affected. Managing component risk means thinking ahead about what happens when a dependency needs to be updated, replaced, or temporarily removed. The build pipeline is where these risks become operational, because it is the process that turns source code into something that can be released. Build pipelines often fetch dependencies automatically, compile code, package artifacts, and prepare releases. If dependency selection and verification are not controlled, the pipeline can unintentionally pull in unexpected versions or even malicious substitutions. Beginners should understand that automation is powerful but also unforgiving, because it will repeat the same mistake consistently at high speed. This is why teams try to make the pipeline deterministic, meaning the same inputs produce the same outputs, so a release is predictable and traceable. When dependency versions are not controlled, two builds can produce different results, which complicates debugging and can hide security changes. The pipeline is also a natural place to enforce standards, because it is a shared path that all code must pass through. If security checks are integrated into the pipeline, they happen consistently without relying on individual memory. Managing risk across the pipeline means using the pipeline as a control point, not just as a convenience tool. This is one of the most important concepts in modern DevSecOps thinking, even at a beginner level. A core practice in dependency risk management is maintaining an accurate inventory of what you are actually using, because you cannot manage what you cannot see. This inventory is often described as a software bill of materials, SBOM, which is a structured list of components that make up an application. The value of an SBOM is that it allows teams to answer basic questions quickly, such as which applications include a vulnerable component, which version is in use, and where the component appears in the dependency chain. Beginners might think this is only for large organizations, but the principle applies everywhere. Visibility enables response. When a new vulnerability becomes known, organizations that can identify affected systems quickly can respond faster and reduce exposure. Without inventory, teams waste time searching and guessing, which delays fixes and increases damage. Inventory also supports governance by making component choices explicit rather than accidental. Over time, maintaining this visibility becomes part of release readiness, because each release should have a clear picture of what it contains. This is how dependency risk management becomes operational rather than theoretical. Another important idea is version control and update strategy, because dependencies evolve and updates can be both protective and risky. Updates can patch vulnerabilities and improve security, but updates can also introduce breaking changes, new bugs, or behavior shifts that affect the application. Beginners sometimes assume that always updating immediately is the safest approach, but in reality, safe updating requires a disciplined process that tests changes and manages rollout. A mature approach includes setting rules for when updates are applied, how they are evaluated, and how urgent updates are handled when security issues are discovered. For example, a team might have a regular schedule for routine updates and a fast-track path for high-risk security fixes. This prevents the common situation where dependencies stay outdated for years because updates feel scary and disruptive. It also prevents the opposite extreme where updates are applied blindly, causing instability. Managing dependency risk means balancing security urgency with operational stability, and that balance is part of a healthy pipeline and release process. When this process is clear, teams can respond to new vulnerabilities without panic. Dependency and component risk also involves trust in where components come from and how they are acquired. When a pipeline pulls components from external sources, there is a question of integrity, meaning whether the component is truly what it claims to be and whether it has been altered. Beginners can think of this like buying medicine. You want to know it came from a trusted pharmacy, not from an unknown source where labels could be fake. In software, trust involves using known repositories, controlling access to publishing, and ensuring that the versions used are the ones intended. It also involves minimizing unnecessary sources and reducing the chance that a malicious or compromised component can enter the build. Another part of trust is provenance, meaning understanding the origin and maintenance of a component, such as whether it is actively supported and whether there is a clear ownership community. Even without going into technical mechanisms, the operational principle is that organizations should not let arbitrary code flow into production without understanding where it came from. When trust is weak, dependency risk becomes supply chain risk, where the pipeline itself can become an attack path. A strong process treats acquisition as part of security, not as a background technical detail. Releases are where all of this becomes real for users, because what you ship is what can be attacked. Managing dependency risk across releases means having a clear release readiness view that includes component status, known issues, and what changes occurred since the last release. Beginners should understand that a release is not just a bundle of new features, it is also a set of risk changes, because updated dependencies can introduce new exposure or remove old exposure. A disciplined process tracks what changed, why it changed, and what testing and review were done. This does not mean long paperwork. It means having enough visibility that when something goes wrong, you can trace back quickly. Release management also includes the ability to respond, such as patching quickly when a vulnerability is discovered. If the pipeline and release process are slow and chaotic, security fixes take too long, and the organization stays exposed. If the process is structured, a fix can move through quickly because the path is known and repeatable. Managing dependency risk is therefore as much about operational readiness as it is about technical correctness. A common misconception is that dependency risk management is just about scanning for known vulnerabilities, but scanning is only one part of a broader strategy. Known vulnerabilities are important, but risk also comes from unmaintained components, unclear provenance, unexpected updates, and dependency sprawl where too many components accumulate without oversight. Another misconception is that dependency management is a developer-only concern, but it actually involves shared responsibility across engineering, security, and release management because it affects the whole lifecycle. Beginners should also recognize that dependency risk is not solved once because the dependency landscape changes constantly. The goal is to create a stable process that continuously monitors, evaluates, and updates components in a controlled way. This includes deciding which components are approved, how new components are introduced, and how old components are retired. It also includes having a plan for emergencies, where a critical vulnerability requires rapid action. When teams rely on ad hoc fixes, they burn time and make mistakes, but when they rely on a defined process, response becomes faster and more confident. That confidence is a major benefit of operationalizing dependency risk management. A practical way to prioritize component risk is to focus on where the component sits in the application and what it can affect. Components that sit on exposed entry points, handle untrusted input, manage authentication, or process sensitive data tend to be higher risk because mistakes there are more likely to be exploitable and more likely to cause harm. Components that are deeply embedded in a critical path are also higher risk because replacing them quickly is difficult. Beginners should see that not all dependencies deserve equal attention, even though all dependencies deserve some visibility. Prioritization can guide where to focus review and where to focus testing when updates occur. Another factor is usage breadth, meaning how widely a component is used across many applications, because a widely used component can create widespread exposure if it becomes vulnerable. This is why organizations sometimes standardize on certain shared components, because standardization makes visibility and updating easier. When you combine criticality, exposure, and usage breadth, you can create a practical ranking of components that deserve the most care. This is how dependency management becomes a manageable problem rather than an overwhelming one. When you step back, managing dependency and component risk across build pipelines and releases is about treating external code as a first-class security concern rather than as an invisible background detail. Dependencies accelerate development, but they also bring inherited risk, including vulnerabilities, maintenance uncertainty, provenance concerns, and increased attack surface. The build pipeline is the operational control point where dependencies are selected, fetched, and packaged, so making builds predictable and traceable helps prevent surprises. Visibility through an SBOM-style inventory enables fast response when new issues are discovered, while disciplined version control and update strategy balance security fixes with stability. Trust in sources and integrity of components reduces supply chain exposure, and structured release readiness ensures that what ships is understood and supportable. For a beginner, the most important takeaway is that modern software security is not only about the code you write, it is also about the code you inherit, and inherited code must be managed deliberately. When organizations make dependency risk management part of normal pipeline and release work, they reduce emergencies, respond faster to new vulnerabilities, and build software that is both easier to deliver and safer to run over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.